Am I audible to everyone? Okay, okay. Right. Let us start our today's session. In the last class, we have started discussing uh, the design objectives of Hadoop, and even we have discussed the importance of HDFS. The important component of Hadoop is HDFS, and various building blocks of Hadoop distributed file system also we have discussed in the last class. So now in the today's class, we will start discussing the map reduce functionality, and then we'll move to the configuration of Hadoop in 3 different modes. So is it visible to everyone? My screen is visible to everyone? Is it visible or not? Okay, okay, okay. All right. So in the last class, we have discussed the HDFS building blocks of HDFS. There, what we understood from the last lecture is the HDFS consisting of 2 different building blocks. Not only 2, we'll have 5 building blocks. So in that, 2 of them are name node and another one is data node, because the major functionality of HDFS responsibility will be done by these 2. What is the HDFS? HDFS is a file system for the Hadoop where we can keep the information, right? How internally it was organized, what way the huge volume of data is going to be stored in HDFS is the name node will act as very similar to the master node in Google file system. So here also it will maintain the metadata of the files which are going to be processed. Okay, and like file name, number of blocks it is going to be splitted, and the mapping between file names and the blocks, these all the things are maintained by name node. And the distribution and the parallel processing will be done by data nodes. That means name node will split the given file into blocks, and those blocks are distributed to data nodes. Data nodes are the places where physically the content will be stored. Where the content will be stored. And the process which the user wants to perform on that file is also applied on the block which is stored at a particular node. Now, data node is responsible for storing the data and as well as processing the data. Processing the data in the sense, it is responsible for processing of data which it was accommodated. Okay, so that is the reason parallel processing. Parallel processing in the sense, say for example, if a file is going to be distributed in, divided into 10 blocks, so those 10 blocks are assigned in this way. Say for example, for node 1 to node 2, these are the 3 data nodes in one rack, and these are the 2 data nodes in another rack. Okay, so these 3 are accommodating 2 of each, and these 2 are accommodating 2 of each. Okay, in such a way, just assume that the total 10 blocks are going to be accommodated by these 5 data nodes. So in this case, data node 1 gets 2 blocks. 2 blocks. Okay, so now data node has to store those 2 blocks in this internal memory, and whatever the map reduce operation that you have specified, okay, so that process will be applied on the blocks which are stored inside the data node. Okay, similarly this particular node, similarly this node. So what happens in that case? Parallelly all the blocks are executed. All the blocks are executed and they are distributed to different nodes. So in such a way it is going to be executed. Now here 2 important points one should understand is the fault tolerance. What we have to do if a name node gets failed, or what we have to do if a data node gets failed, because these are the 2 places where our entire data is resides. Okay, so because name node is going to maintain the metadata, the namespace information and all, whereas data node is physically holding the data. Okay, so that is the reason why we need to focus on these 2 failures. So if a data node gets failed, what we have to do? How do we identify whether a data node is working or not? With the help of heartbeats. With the help of heartbeats, we can verify whether a data node is in functioning or not, or active or not, right? If the name node did not receive any heartbeat from this data node 1, what it assumes? Simply it assumes that the data node 1 is not in active. There is some problem. So immediately what it does? The name node will activate other data node where the secondary replica is available. As I told you in the previous class, the whole information, the 10 blocks are going to be replicated and those will be stored. One is at local mode and remaining 2 are stored at remote places. Remote place in the sense other than this cluster where your local system is present, right? Suppose, say for example, first block is stored in this data node. Okay, this will be considered as a local node. Okay, remaining 2 replicas will be stored in, assume that this is another cluster where we can keep the remaining 2 copies of this first block. right? So you just remember in such a way, because if something went wrong with this data node, sometimes it may be corrected this entire block. So that is the reason why we need to be placed it in remote places. Okay. So whenever if this data node, if the name node did not receive any heartbeat from this first data node where the block 1 is available, immediately it activates other place where the secondary replica is available. Say for example, this is the node which contains the first block secondary replica. Immediately what it does, it activates this particular data node. Okay, you just start functioning of this particular task on the data which you have accommodated. Okay, so in such a way it will pass the information, and by passing the information in such a way, it keeps, so the process is going on in a proper way. That means without losing the performance, even though the system gets failed, okay, the process or the working will not be stopped. Okay, so in such a way we will overcome the fault tolerance if a data node gets failed. Then okay, fine. Then what about a name node failed? Okay, if a data node is going to fail, if it was failed, then you have a mechanism how to handle it. Then what about name node? So in the case of name node, whatever the content which resides in the name node need to be backed somewhere. It doesn't mean that it is an alternative place or it is an alternative node for the same node. So here we will maintain secondary name node which will keep the essential functionalities of the name node. Once again I'll repeat. Here secondary name node will be there. The job of that secondary name node is it will keep the essential functionalities information of the name node with the secondary name node. Right? Whenever if a name node gets failed, what happens? Immediately we will allocate the task to some other system. Okay, in that system we'll restore the content which is available at secondary name node, because secondary name node contains all essential functionalities information of name node. So immediately with the new system we will restore the content which is available at secondary node to the newly configured name node, so that what happens, without disturbing, suppose if there is no such kind of mechanism, if there is no concept of secondary name node, what happens in that case? If the name node gets failed, the entire system is going to be collapsed, because it is the entry point for the entire system. So that is the reason we'll keep that information at some other place. That place is, the name of that place is called as secondary name node, which the use of that secondary name node is whenever if it gets failed, it will help you to restore the whatever the previous information that it will have. Okay, periodically it was also be updated, so that is the reason always it will have most updated information. Okay, so that information will be restored into the newly configured name node, so that immediately after starting the functioning of name node, what it does, first it restores the information on the secondary name node. So now it has some information regarding the files and all. With that information, it starts conducting the poll. That means it passes information to all the data nodes. You should respond with the available blocks with you. Okay, in such a way it will pass some information to all the data nodes. All the data nodes will be responded with the help of heartbeats by saying the blocks and all. So then in that case, name node will compare with the available data, existing data, with the newly received polled data. If both of them are same, then it is fine. If the data which is received from the data nodes are newer than the data which is available with the name node, so automatically what it does, it will be updated in it. So in such a way, even though the name node gets failed, within less amount of time we are able to restore and we can restart the functionalities of name node. Clear? Is it clear to everybody? Because this is the basic functionality which everybody should understand. Is it clear to everybody? Or you can unmute yourself and you can ask a question if you have. Anyone of you? Anybody? Any queries? Is it clear? What is the functionality of the name node? What is the functionality of the data node? And what way we can restore the data if either name node gets failed or the data node gets failed? In both the cases, what way we are supposed to, not we, how the HDFS is developed the mechanism to handle such kind of situations. Is it clear or not? Is it clear or not? Okay. Right now, let us see, that is about HDFS. Now, let us see the map reduce functionality. Right? So because there we need to discuss about the remaining two components. One is job tracker and another one is task tracker. As of now, we have discussed the three components. One is name node, secondary name node, and data node. Remaining two components we will discuss with the help of map reduce programming model. These all things I think we have discussed. We have covered in the previous class, right? Okay. Now, let us talk about the map reduce programming model. I think in the last class we have discussed this diagram and this one also. Now, the entire map reduce framework will be operated on the key value pairs. Key value pairs as hashing, as you are aware of that hashing. Even we have discussed while discussing the sets and maps, there we have discussed this key value pairs also, and you know already. So this mapper logic, basically we need to develop two different methods in any analysis program. One is for mapper function and another one is for reducer function. What mapper does, what reducer does, we'll see. Okay, so it reads data as key value pairs and the key is often discarded. After processing it, the key will be discarded. So it accepts the information in the form of key value pairs only. It accepts the information in the form of key value pairs only. Okay, and it produces the output, the mapper logic produces the output either 0 or more number of key value pairs. Okay, and first we will discuss the diagram so that you will have some idea, and then we will discuss about what exactly the shuffling and what exactly the reducing. Here I was taken an example. Here I'll give the input as different words. Simply you can remember that a word document which consisting of several sentences. Okay, text. So in my case, I was considered 3 lines, each line consisting of 3 different words. Okay, it will not be the same in all the cases. Our assumption is always the file size will be large in size. Okay, large volume of data. So, but for better understanding, only here I was considered 3 lines with 3 words only. Okay, right. So the first line will be supplied as an input to the first mapper logic. First mapper logic. Here you need to observe here important point is first mapper logic means you are supposed to write 3 different mapper logics. No, we will write only one logic. That logic is going to be executed in all the places where the blocks are available. As I told you, data nodes are the physical storage places of the blocks of a file, okay, and along with that they will also process the data which they accommodate, okay. Whatever the block that it was stored in the data node will be processed by data nodes itself. So here only one function, the same function will be executed on the block which it was supplied to this particular data node, and it will ask the same mapper logic will be executed on the block where it is, which is available at data node 2, similarly data node 3. Okay, don't be confused. We will see an example program also how to execute this particular one, so that you will get better idea. Okay, until then you just remember that whatever the input that you have given, that need to be split into equal blocks, equal sized blocks. Here our block size is 64 MB. 64 MB. Of course, current versions of the Hadoop is able to process 28 MB sized blocks also. Okay, but in our case we'll assume only the 64 MB. Okay, this is the input file. As you understood from the architecture of HDFS, whatever the file that it was submitted, the name node is going to be split it into blocks. Each block will be in equal size. So with that mechanism, this is the input file, and this is going to be divided into 3 equal parts, right? 3 equal parts, and these blocks will be stored at, what is the next step? These blocks should be stored at data node. Assume that this is the data node 1, this is the data node 2, and this is the data node 3. For these 3 data nodes, 3 blocks have been supplied. Now that is the scheduling, job scheduling. Okay, these all process will be taken care by, that means dividing and allocating to the data nodes will be taken care by an important component in the name node is called as job tracker. What is the name? Job tracker, which will take care of scheduling the jobs and supervising the data node heartbeats, and all the things will be taken care by the job tracker component which is present in the name node. Hope you all clear, right? And another component which resides in the data node is task tracker. Task tracker. The job of this task tracker is whatever the task that it was allocated to the data node 1. Data node 1 will be supervised. That means in our case, this is the first block which is allocated to data node 1. Now on this data, we are supposed to apply a mapper functionality, and then we'll produce the output. We'll produce the output. Okay, so this entire task execution will be done by task tracker, which tracks the execution process of that particular task. Right now, here that is the task tracker and job tracker. Those are the 2 important components of HDFS. Job tracker is responsible for scheduling the jobs to the various by using various data nodes, whereas task tracker which tracks the execution process of a particular task. Of a particular task in the sense, here your task is this mapper logic. What you are supposed to do here itself is, this is the input file. So for that, what you have to do is whatever the count of these words need to be placed here itself. That means a deer is 1, beer 1, river 1. In such a way, you can filter it. For producing the output in this way, you are supposed to write the code. You are supposed to write the code. That means reading the sentence and dividing it into words. How do you identify whether it is word or not? Whenever if a blank space is appeared after a sequence of alphabets, then we can consider it as a word. Right? Immediately, whatever the characters that you have scanned before appearing of a blank space will be considered as a word, and you can place the value as 1. Like that, you will continue the process till the end of the file, till the end of the file in the sense till the end of the block. Okay. In our case, we will process only the block, not this entire file. Right. Similarly, node 2, similarly, node 3. So that is the functionality of the mapper. That means it is your responsibility to write the code in such a way. Okay. Right. And then the next phase is shuffling and sorting. So here what we did is in alphabetical order, what will be the, whatever it may be the first alphabet of a word. So in our case, no word starts with A. So that's why we'll move to the second alphabet B. So here bear is the word which starts with the B. So that's why all the words which are starting with the B alphabet will be placed at one block. Similarly, C, D, E, like whatever it may be the words that you have. Now, the reducer job is, here the reducer job is, it need to be consolidate the outputs. Consolidate this output. That means here, just simply, instead of representing it as two different words, it simply counts these and make it as a single word. And that means bear 2. This is the key and this is the value. Bear is the key and 2 is the value. Right? And this output will be written to the output file. Similarly, the second car 3, deer 2, river 2. So here, how many phases are existing? One is mapping, another one is reducing. Actually, these are the major parts of the map reduce programming. But what happens? What is the process before applying the mapper logic, and what is the what are the outputs that are produced after applying the reducer logic? What is the process that will be that we are supposed to execute right from the beginning to the end? You just once again understand. We'll try to analyze yourself, and then we'll move to the next. Initially, we'll have a file to hold the input information. Okay, that is called as input file. Input file will be split into blocks, and those blocks are supplied to the various data nodes with the help of job tracker component, which should be present in name node. Okay, and here in the data node applies the mapper logic on the block which it accommodates, and those operations will be tracked by task tracker. It is another component of HDFS which is available at data node itself. Okay, so whatever it may be the outputs after processing that block, whatever the output that it was generated by the mapper logic will be shuffled and then finally consolidated, and those consolidated reports will be stored at another file called as output file. So here we need to create an input file, and we need to create an output file, and we need to create the logic, mapper logic and reducer logic. Okay, now I'll show you how we will develop the mapper logic and reducer logic in an example, not for the illustration purpose, just for understanding. So my screen is visible to everyone or not? Is it clear? Is it visible or not? Okay. Okay. Right here, you can see these are the some of the important packages that we are supposed to be import into our program. Don't worry, we will discuss elaborately about all these packages and all. Okay, here our program is public class word count. Okay, and this is the mapper logic. This is only the mapper logic. See how much length it will have. Just only 2 lines, 3 lines of code. This is the for the object declaration, and these 3 are for splitting the data. Okay, and this is the reducer logic. This is the method, reduce method. Here you can see this is the reduce method logic, right? So, and this is the main program. Okay, so irrespective of the size of the file, whatever it may be the size, if you install your Hadoop in fully distributed mode, you can execute whatever it may be the size of the file. That means, suppose if your input file contains 100 TB, yes, we are able to process. Yes, we are able to process. How? The 100 TB data is going to be split into blocks, and those blocks are distributed to various data nodes which are present in the various clusters. Okay, and parallelly will perform the operation on the blocks also. So in such a way, without losing our performance, we are able to execute the program. Okay, so don't worry about this code, how to write and all. We will discuss each and every line, and essential information regarding this also we will discuss. Don't worry about it, how to create and all, we will discuss, right? Right, now let us try to understand, once again reveal, not understand, you know very well about it. Just we just try to recollect what we know. So the output from the mapper is sorted by the key. The output from the mapper is sorted by the key. Here you can observe that shuffling chart, this one. The mapper, the output of the mapper will be sorted by the key. Key in the sense, here will sort the elements, only BR elements here itself, car elements, alphabets, starting with B, starting with C, starting with D, starting with R. These are the keys, right? And get a list of all values associated with the key as an input. Okay, and the reducer outputs 0 or more key value pairs. All values with the same key are guaranteed to go to the same machine, as all the beats are going to the same reducer mechanism, and all cars are going to the same reducer mechanism in such a way. So coming to the reducer, which called once for each unique key. For each unique key, reducer 1 will handle this beer 1, reducer 2 will handle this one. So it will handle only one unique key. Suppose sometimes we will assign some another key to this particular one also, right? In that case, first produces the output for this particular key, and then it will go to the next one. So here a lot of research is going on in the performance aspect. How many reducer methods we are supposed to maintain? How many mapper logics, mapper system, of course, how many reducer systems we are supposed to maintain, whether it is possible with a single reducer, or we are supposed to allocate a number of systems for executing the reduce method. So this is some research is going on this aspect also. All right. So the reducer outputs either 0 or more final key value pairs. So usually just one output per the input key, right? So this is about mapper and reducer logic. So once again, quickly reveal what we understood from the past two classes. Name node, it holds the metadata for the HDFS, and secondary name node performs the housekeeping functions for the name node. Whatever the essential things that are present in the name node will be maintained with the secondary name node, which will help you whenever if a name node gets failed, or for the restarting or restoring of contents of the name node, we'll use the secondary name node. And the data node, which stores the data, actual HDFS data blocks, right? So the block will be stored at a data node, and job tracker, which manages the map reduce jobs. How the mapper logic should be executed in data node, and other systems where the reducer logic is supposed to be executed. These all things will be taken care by the job tracker. So task tracker monitors individual map and reducer tasks, right? Which supervises the data node functionality in terms of map and reduce tasks. So that is about the important building blocks of HDFS. When if you got a question in external examination, explain about the building blocks of HDFS, you are supposed to, or important components of HDFS, you are supposed to explain all these 5, right? Okay, this is all right. So these are the other tools which we are supposed to be used along with the Hadoop. So Hive, we'll discuss in the 5th unit. Hive, Hadoop processing with SQL. Just like it is in SQL, you may feel while writing the queries in Hive, you may feel that it is similar to SQL. So here it is used for retrieving the data from HBase database. And Pig, it is also you are supposed to be learned in 6th unit. It is a scripting language, Pig Latin. Okay, so it is used to process the Hadoop processing with scripting. And HBase is the database. Cascading is meant for pipelining and filter processing model. And Flume, which is used for large scale data movement from one place to another place. So these are the different other tools which we are using along with the Hadoop. Okay. Now let us see the configuration. How to configure the Hadoop in the 3 different modes. First, we will look at it into standalone mode, and then we'll move to the pseudo distributed mode and fully distributed mode. Right, as you know, Hadoop can be installed in 3 different modes. One is standalone mode, and another one is pseudo distributed mode, and the third one is fully distributed mode. The standalone mode is also be called as local mode. By default, Hadoop is installed in that mode, non-distributed mode. Okay. In the standalone mode, both name node and data nodes are running at the same system or same cluster, same system itself, right? And the process will be executed with a single JVM, Java Virtual Machine. Okay, that is standalone mode. Whereas pseudo distributed mode, both name node and data node are running on the single system, but the processes are handled by different JVMs. Okay, so these 2 modes of operation usually will be used for debugging or testing your application. Okay, once you tested your application in by using any one of these mode, and then you can physically test it in the pseudo distributed, fully distributed mode. Okay, but in real time scenario, people usually uses fully distributed mode because there they want to handle huge volumes of data. But when we are writing our simple applications, the standalone mode or pseudo distributed mode is enough for us. But don't think that enough for us in the sense we will test our applications with the help of these 2 modes. Okay, and even we can configure the Hadoop in fully distributed mode also. We will see the configuration steps, how we are going to be install the Hadoop in 3 different modes, right? So the first step in any mode is creating the user. You need to create a user for your Hadoop, right? So here we'll use the SU command to move to the root, your open root. That means directly it will create a root for your particular user. SU stands for super user actually. Okay, and you can give the password to that one also, right? And after that, you can add, whenever if you reaches the root, you can start adding the Hadoop users. So that can be done with the help of user add Hadoop. Okay, and password, whatever you want, you can add. Of course, usually we will do with the passwordless user creation, but it is possible to create passwords also. Right now, SSH setup key generation. This is more important, because we are sharing our information from insecured data lines to secure line. So in that case, what happens is, when we are communicating between the two terminals, the communication, the data processing should be, or the data transmission should be more and more secured. Okay, so for that purpose, here we'll use the SSH, secured shell communication, by using RSA algorithm. You might have heard about RSA algorithm in CNS, okay, which is a public key cryptographic algorithm or asymmetric cryptographic algorithm, right? So you know the difference between symmetric and asymmetric cryptography. In the symmetric key cryptography, we will use single key for both encryption and decryption, whereas asymmetric cryptography, we will use two different keys. One is for encryption and another one is for decryption. Okay, so RSA algorithm is a public key cryptographic algorithm. Actually, it is a key exchange algorithm. Okay, and with the help of that algorithm, we will try to generate the keys. By using those keys, we will try to authenticate the users. Okay, so in such a way, we'll use that algorithm. By using that algorithm, we'll try to generate the keys. SSH key generation, RSA, and those will be displayed, and those will be authenticated. chmod 600 is the command in the Linux which is used for authorization of the users. Okay, whatever the keys that are generated with the help of this RSA algorithm, those will be authorized with the help of this particular command. And once you created user, okay, we will start installing Java, because we are supposed to write the code in Java. Don't think that Java is only the language. You can write the code in Python, you can write the code in some other programming language, even C++ also. Even C++ also you can write the code, and that code will be executed in Hadoop environment also. Right? Usually for pipelining, we'll use the this particular one. So, but majority of the case, because the framework, the Java, the Hadoop itself, it was developed by using Java framework. So usually in our case, we will write majority of the cases, we'll try to write the programs by using Java only. So for that, we'll install the Java. Okay, and you know how to check whether your Java is installed successfully or not by writing the command Java version. Okay, so these are the installation process for the Java. Okay, you can you know how to install, because you are familiar with the Java, so you know how to install the Java into your system. And after that, that Java should be available at a location which is open to all. So that is the reason open root. Open root in the sense, our root is SU, and you just type the password, okay, and move the JDK, whatever the file that we have downloaded will be moved to this particular location, user local, which is the common place where every users of the Hadoop are going to access. Right? And then we'll exit from this. Next, now you need to set the path. While executing Java programs, we are supposed to set the path. So here we need to export two different commands. Export Java home to where is equals to, this is the location where our Java file is available right now, because in the previous example we have moved JDK 1.7.0_71 to user/local. So that is the home, and export the path. Simply the /bin, Java home which we have uploaded, followed by the bin. Right? You know very well about the path setting. And then whatever the JRE jar files are also be installed into our location. Use the following commands to configure Java alternatives. Okay, for Java compiler, jar files, these all things need to be made available at the common location, that is user./local. Now, this is the step for installing Hadoop. So you can download the Hadoop from the by using the command wget followed by the website address where the Hadoop is available. You can download it. This is the 2.4 version. Now 3.0.3 is the current version. Even if you want, you can download it. So before going to download it, you need to verify the configuration of your systems because it requires somehow some high configurations, right? And another important point is this entire process, whatever the process which we are discussing right now, is meant for installing Hadoop in Linux environment. For Windows environment, it is different. Okay, usually majority of the places the Hadoop is running on Linux operating system. If any one of you are having Linux in your desktops or laptops, you just try to install this so that you can execute the programs at your system in the standalone mode itself. Right? Sorry, what is it? Any queries? Somebody is talking. Any queries? Correct. So we'll move to the common location for the users of Hadoop, and then we will download the Hadoop file, which is a tar file. The tar file is, you can assume that it is just like WinZip, but it will be used for transmitting data over the network. We are supposed to convert it into tar files. Okay, and then we'll just extract those files. Okay, and then we'll exit. So now you have installed Hadoop. So in the next class, we will see the remaining concept of configuring Hadoop in 3 different modes. So any queries? Any queries? And today's options are roll number 9, 12, 13, 15, and 54. Okay. So if you have any queries, you can place it in the drop box, or you can unmute yourself and you can ask, no issue. Lokesh, are you there? I think Lokesh is second section. Okay. So any queries? No? Okay. Now I'll end the session. We will discuss the remaining things in the next class. Okay. Thank you.